Okay, so now let's talk about some questions that you're going to be asked about this because yes, that's the whole thing. I mean, there's not a lot other to it except for a couple of vocabulary words, but this that I wrote right here, this right here is the interpretation of the results. This is an interpretation to the interpretation to the answer to the question is 130.1 comma 137.7. That's the confidence interval. And then sometimes I think it's on your test, they're going to ask you to write this confidence interval, and writing it like that is perfectly fine. But they're also going to ask you to write it as an inequality. And when they want you to write it as an inequality, you still use parentheses. You still write 130.1. But instead of putting a comma, you put less than x less than 137.7. Okay. So this is called inequality notation. Okay, so just let me tell you that if it asks for inequality notation and you have a brain fart or something on the test, and like I said, I don't even know yet how I'm going to give you the test. I'm asking some of the other stat teachers what they're doing. But let's assume right now that you're going to take a pencil and paper test at your house and email it to me. Let's assume that it's going to say write it in inequality notation. If you forget this and this is all you can give me, that's fine. There will only be a minor deduction for not being able to write it like this. So the what the StatCrunch gave you right here, lower limit, upper limit. Oh, wait, did I write that wrong? 132.7. Oh, my goodness. Some of you are probably trying to correct me 100 times since then. That's 132.7, 132.7, 132.7. Yeah, I have that written on my paper. Okay, so 132.7. So that is the 95% confidence interval. Okay. Now, what we have not talked about is how would you do this by hand? And the reason even though you're like, I'm not going to do it by hand, I'm always going to do it by that. Well, I may ask you about any one of these parts. So I may ask you not to give me the 95% confidence interval. I may ask you for the margin of error. Or I might ask you, let's look at all these words right here. So margin of error is a vocabulary word that you need to know. Be sure you know these other ways to phrase it. The maximum error of estimate or the error tolerance. Be sure you know those words. Let's see, the population mean, the margin of error is this. Where do they tell us what this is? Because you need to know what this is right here. And okay, so I will come back and I want to make sure that I'm going to give you the right terminology for that. I can't remember. One of these is, I think that's the critical value. I think that's what it is. But I will double check it and before I give it to you for sure. But it is what they're asking you for right here, and you can calculate the margin of error without having to use this formula right here, because we find the margin of error right here. The margin of error is how far it is from here to here, and then how far it is from here to here. That's going to be your margin of error. This is your ME right here. All right. So when they gave us this thing right here, that's what they're showing us. They're saying, okay, so our population mean, because that's what mu is, our population mean is going to be somewhere between the sample mean, that's what x bar is, minus the margin of error, and the sample mean plus the margin of error. So since we can actually subtract those two and figure out how far apart those two are, since we can actually subtract those two, we can find out what the margin of error is. So the margin of error can be calculated by taking 131.4 and subtracting 130.1. Or you could do it this way, and it should be the same answer: 132.7 minus 131.4. And if I did that right, and I'm not going to use either one of my big calculators, I'm just going to use my regular old calculator right here because I don't want to use the wrong calculator for somebody. 131.4 minus 130.1. That comes out to be 1.3. 1.3. And I believe this right here will come out to be the same thing, 1.3. So that means that my margin of error right here is 1.3. You take this number and you subtract 1.3 from it. 131 minus 1.3, you get that. You take this number right here and you add 1.3 to it, and you get this number right here. So that's one way you can find the margin of error if that's what they wanted. You can go ahead and find the whole confidence interval and then subtract how far each one of them is from the sample mean. Okay, so that's one way you can do it. If you're doing it by hand and you're using this formula right here, then this formula says to find the margin of error, you're going to need a z value for this confidence interval. Okay, so again, look, see, this is not an x-axis, this is a z-axis. So you're going to have to get a z value for those x values for this confidence interval. So there's a couple of different ways you can do that. The first thing you have to do, though, is you do have to figure out what these empty spaces are right here. Okay. And remember, this formula up here does that for us. We need this empty space. 1/2 times 1 minus the confidence interval. Why is it 1/2 minus 1 minus confidence interval? Okay. Well, we already know that this is 95% of the area underneath that curve. So this right here and this right here together is 1 minus 0.95. Okay, so that's 0.05. That's 5%. But that 5% has got to be divided into two parts, the part over here and the part over here. So that's why we divide it by 2. So the answer to this right here is 2.5% or 2.5%. So this right here, this area over here is 0.025. And you can go now look up that area 0.025 and get a z value. Now remember, a z value, a z axis down here, this is going to be 0. Okay, and we're looking for a z value for that 130.1, and we're looking for a z value for this. And so the z value is going to be found by finding this area. Why this area? Because it's the area to the left. And then whatever the z value is right here, this z value and this z value are going to be the same. This one's just going to be negative. This one's going to be positive. So we're finding z for our confidence interval, the z value for our confidence interval. That's what that little subscript c is for. It's the z value for our confidence interval. And I think that this has a name. I will look it up in just a minute. I can't remember what it is. But we're going to go look and see if we can find it on our table. So we're looking up 0.025. Oh, and look, we found it yesterday, 0.025. There's the 0.025 right there, and it's negative 1.96, negative 1.96. So this z-score right here, this z-score is negative 1.96, and this one is positive 1.96. Now, when we write the value down right here, we always use the positive one, 1.96, and it's just understood that they're going to be the same one, 1.96, positive and negative. Now, I want to show you something else, though, on your table. On this side right here, critical values, that's what they're called. I knew it had a name. Critical value for these four confidence intervals are listed. So if they ask you for an 80% confidence interval, 90% confidence interval, 95 or 99, they're already listed. They're already calculated for you. You don't have to look it up. But if they give you any other confidence interval that's not on here, then you have to go through and do what we just did. So you would have to do that, subtract it from 1 and divide by 2, and then look up the area. But since it is on this one right here, we see that we did it right. This is negative 1.96, and this is positive 1.96. And I'm going to stop it right here because I have no idea how long I've been talking, and I don't want it to be too long.